Hello guys, so now let's check the next exercise. It's called Minimum Window Substring. It's a hard one, and like always, let's check the conditions. So you are given two strings S and T, and we need to find a minimum substring in S that contains all characters from T. If no such substring exists, we need to return the empty string. And below we have some examples where we have string, let's say A, D, O, and so on. And the second string which we want to find in this longest substring is A, B, and C. And this substring is, so the results should be B, A, and C. Yes, from here. Yeah, because here we have A included, here we have B included, and here we have C included. And one important thing is that the order is not important, and it's not required that these characters to be placed one over another. And below we have another example where we have only one character, and the answer is also only one character. And in that case we have only one character, but we want to find B, and this character is not a substring of the first string, so the response is empty. So now, like usual, let's answer to some questions. Let's check what kind of questions. So when is a window valid? What do we need? Actually, what do we do when the window is valid, and what pattern fits here? So I would recommend you to think a couple of seconds, maybe minutes, and to answer to these questions. And let me do it right now. So when is a window valid? When it contains all characters from T with at least the required frequency. What do we do when the window is valid? Try to shrink it from the left to find a smallest valid window while saving the current minimum. And what pattern fits here? Sliding window, in my opinion. So expand right until valid, then shrink left as much as possible. I think all of this should be already familiar for you if you have watched previous videos. So now let's check how we can implement this in the code. So let's move. So let's declare our method. Let it be public static. We want to return a string. Let's call this method minimum window substring. Yes, and we will have two arguments here: string, let's say word1, and string word2. Okay, perfect. Now let's define some variables. So usually when we use sliding window technique, I use two variables, left and right. So let's declare them. Left, which is equal to 0, and int right, which is equal also to 0. Okay, perfect. And let's also define a variable where we will store the minimum current value, let's say value, and initial value will be integer max value. Yeah, in order to be sure that when we will compare, we will find at least a value minimum that the maximum integer. Okay, then also let's declare a string result. Yeah, so here we will store our result. Okay, and also we'll need two things. You will see, I think, and we'll understand why do we need this thing a little bit later, let me declare them int need. So this is a variable which will show us how much elements we need to find while we will iterate through our string, and also we will need int now have variable that will be 0, yes. So the difference between these two, that in need we will store how much characters, let's say, we need to find in our string in order to match the condition, and now have will show how much let's say characters and frequencies we already found. Yeah, and if need and now have will be equals, it means that the condition match, and we can do some logic. Now also let's create two maps where we will store the character and frequencies for that characters. One will be for the window and another will be for the string which we are searching. So map character integer, and let's call it character frequency, new HashMap, and another one character integer, and it will be character, let's copy this, character frequency inside window. Perfect. Now let's create a for, because it will help us to iterate through our string. Alright. Now I will explain why we need this for. Int a is equal to 0. For 2 length I++. So I want to iterate through where2 and to initialize my character frequency map in order to know what characters for what characters we are searching and what should be their frequency inside the string. So let's do this. Character frequency, put word2, add, and character frequency get or default word2 char I. The default value will be 0 plus 1. Okay, perfect. So we defined a map with characters and their frequency, which we need to find. And now let's initialize our need variable, which will be equals to character frequency values, character size, the character frequency values dot size. All right. So and now let's create actually let me check something. Oh, okay. Now let's go and create a while loop in order to iterate through our word1 while right is less than word1 dot length. I think all of this should be very familiar for you if you have resolved previous videos. And now let's include in our character frequency inside the window map the current element. So let's put it inside this map, word 1 char at right, and character frequency inside window, get word default, word 1 char at right, default value 0 plus 1. Okay, and now let's make a verification. Now I will explain for what do we need this. So we want to check if character frequency contains key word 1 char at right, and character frequency gets word 1 char at right, equals to character frequency window get word 1 char at right. Okay, let me check where I have done mistakes. So okay, equals character frequency get, yeah, here is the problem. So now we can continue. So why do we need this condition? So in case if the current element is in our map with required characters in character frequency, and if the frequency is equal to the current element, then we can increase our now have value. Okay, and now we can move further, and we want to create a while loop where some logic will be executed if now have is equal to need. And why do we need this? So let's imagine that we have a situation that we need to find ABC, let's say, in a string JHABC. And in that case, we need to move our left pointer till that condition will not be true. And in that case, we will find out that actually the length is not 5 but 3, because we will move our left pointer until the condition will be false. So I hope it's clear. If not, you can leave a comment below and I'll try to explain more a little bit clear. So now let's check if minimum value is greater than current length between left and right. So let's do something like this: right minus left plus 1. Then in that case we will need to reinitialize our mean value variable, which will be equal to right minus left plus 1. And the result will be a substring from word 1, which will start from the left pointer to right plus 1. Why plus 1? Because in Java, when we indicate substring, we indicate the index here, which will not be included in the string by so because of that we add plus 1 here. And now after we have done this check, we can move, let's say, our window. And because we will remove the left element, we will need to decrease his frequency. So let's call our character frequency window, and here we will decrease the frequency for left element. Word 1, char at left, and character frequency, character frequency inside window get word 1 char at left, and here we'll need to do minus 1. Okay, perfect. And now let's make the last check. So if element which we have removed is mandatory, then we need to check if the frequency is less than required, and in that case we will need to decrease our now have, because let's imagine that you need let's say 2a, and now you have removed you moved actually left pointer to the right, so now 1a is not in our window, so the frequency will decrease and it will not match the requirements. So we will need to check this. So let's do this. So character frequency, if character frequency contains key with 1 char at left and if character frequency window gets words 1 char at left is less than character frequency get word 1 char at left, then in that case we will need to decrease our now have. And after this we can move left to the right, and here we need to move right to the right, and at the end we will need to return the result. And now let's check how this method is working. So minimum window substring, let's say a b f g h t a b, and we want to find, let's say, a b. So the response should should be, yes, correct. Actually A, and somewhere B was lost. So let's check what is the problem. Oh no, actually it's true, because we have B here, so we don't need this B. Yeah, everything is right, but let's try to remove this B and check now. Yeah, now the result has changed. So method looks to work fine. Now let's analyze the solution. So the time complexity is O n plus m. This is because we iterate once over word 2 with length m to be the frequency map, and then use a sliding window over word 1 with length n, where both pointers move through the string at most once, while HashMap operation run in O1 on average. And the space complexity is OK, because we store characters frequency in two maps, where k is the number of unique characters, which is at most 128 when working with ASCII codes. And yes, I think in the next video I will show you another approach, how you can optimize this solution using ASCII codes of characters. So thanks for watching, and we will see in the next video. So when I was watching the video, I have noticed that actually here I have a small mistake. So here we don't need to the need don't need to be equals to value size, but with a map size, because we want to know how much unique elements do we have. So that was the mistake, and I hope that it helped you. Thanks being with me and for your support. Bye.